One. All right. We're recording now, okay? Okay, so this is a summary of everything you should have learned up to now. All right? Vertical translations, if C is greater than 0, it goes up. If it's less than 0, it goes down. Horizontal translations, if D is positive, it goes to the right. If D is negative, it goes to the left. Vertical stretches and compressions. This is another way of writing if A is less than -1 or if A is greater than 1, then you're going to have a stretch. You will have a compression if -1 is less than A is less than 1. Okay, I'm just showing you another way to write this. This should be or. Horizontal compressions and stretches and compressions. So if K is less than -1 or K is greater than 1, you will have a horizontal compression by a factor of K, and -1 is less than K is less than 1. So if K is like -1/2 or a +3/4, you're going to have a stretch. Reflection about the x-axis, and when the x is negative, then it's a reflection about the y-axis. This brings it all together, okay, right there. Well, I don't know if we'll have time today to do an example of when a point xy is transformed. It becomes the point x divided by k plus d, a times y plus c on the graph once it's been had a combination of transformations applied to it. If I can't do it today, I will do it tomorrow, okay? But we're going to do examples of graphing using transformations today. Some things this points out, before you describe or graph using transformations, you need to factor out the k. So if you have a graph y equals 3, 2x minus 10 all squared minus 7, you have to factor the k to get the correct horizontal translation. Always factor k. Okay? Always remember, when we are applying transformations or describing transformations, we must ensure they are done in the correct order. Okay, so you always do stretches, compressions, and reflections before the sliding left and right or up and down. Okay, so on the next page, I'm going to illustrate all of this with examples to reinforce these concepts. On the next page is I wrote out an example in full. The example is this one down here, I believe. This one here. Okay. And I just describe how everything's done, and I show it step by step. I'll let you study that one. However, what I am going to do is do some specific examples with you. Okay? So let's start there. Okay. This question says graph y equals -4 times x plus 3 all squared plus 6 using transformations. Then we'll describe the transformations. We'll talk about how the description is different from the textbook. And then we'll state the domain and range. So let's first start out by graphing. The first thing we're going to do is graph our parent function. So notice there's x plus 3 all squared. We know right away our parent function is y equals x squared. So whenever you graph using transformations, you start with the parent function. So let's do that. Now this is where this by now should be second nature to you. When x is 0, y is 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. When x is 3, 3 squared is 9. Similarly, we can just get the reflection points in the axis of symmetry, and we can just graph that, and now we have it. There's graph number 1. Okay? That is the parent function. The next thing we're going to do is handle the a, which is negative 4. We're going to do that in one step. We're going to reflect it, and we're going to do a vertical stretch by a factor of 4. So I'll do that right now. When here y is 0, negative 4 times 0 is 0. When y is 1, negative 4 times negative 4 times 1 is negative 4. 1, 2, 3, 4. When this is 1, negative 4 times negative 4 times positive 1 is negative 4. Notice this point is invariant because it didn't move under this transformation. So negative 4 times positive 4 will bring me down here. So we're just going to draw what the grid allows. So this is my graph number 2, and what I've graphed is y equals negative 4x squared. That's what I've graphed. Before we continue, don't forget to label your x and y axes. Make sure there's arrows to indicate it goes up forever. Now I can handle the translations. So I'm going to finish off the graph now. I'm going to do the horizontal with the vertical all in the same step. Okay, so this means, think of x as disobedient. You tell it to go to the right and it goes to the left. So this is really a translation of 3 to the left and up 6. So think of y as obedient, stretch by a factor of 4, we stretched it. Reflection, we did that. But x is, we go up 6 for the y value, right? This and this affects the y value. This affects the x value, and x is disobedient. We go 3 to the left instead of to the right like you would think, and then it's up 6. So we go 1, 2, 3, 1, 2, 3, 4, 5, 6. Every point, remember to do the red one. 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so that's number 3. Okay, so let's describe it now. Okay, yep. Okay, so actually that's a good question. When the question says using transformations, okay, you have to show it as a series of steps. So you start with the parent, and then you do the stretch, and then you do the translations. Okay? Yeah. However, if it doesn't say anything, you can do it that way. Okay? Okay, description number 1. Reflection over x-axis. That's what the negative does, right? Vertical stretch by a factor of 4. 3. Horizontal translation left 3. 4. Vertical translation up 6. 'Kay? Let's now describe the domain and range. Domain, well, it's a quadratic function. X can be anything. Let me correct that. Should write will be consistent. X such that X is an element of real numbers. Range is, well, our vertex is negative 3, 6. The biggest value y can be is 6. So y such that y is less than or equal to 6. Y is an element of real numbers. Okay. So hopefully everything you've done in the past few days is starting to be consolidated here. It's starting to make more sense or being clarified. Yep. Here. Yep, absolutely. You write it for the given graph here. Whatever that. Yeah. You just write it for the final graph. Let's try, I'm going to do 2 more with you. Okay. This one is important because remember I told you you always have to factor the k. Here k was positive 1, so it didn't make any difference. But here k is negative 1, and that will make a difference. Okay? So let's do that. We need to rewrite the equation. Factor k. Okay, so this will be y equals negative 3/4. Factor out the negative 1. Okay, so always factor the k in order to get the right transformations. If you don't do that, you won't have correct transformation. This is a very important step. Put a star there, okay? Because you can't forget that. So again, make sure you label your axes. The first one we are going to graph is the parent function because it is this one doesn't say anything, but I want to make sure we illustrate using transformations. So number 1 is going to be y equals x squared. So again, just get that parent function in there. All right, it should be straightforward to you now. Number 2, we'll do y equals negative 3/4. quarters x squared. Now this is going to be a reflection over x and a vertical compression by a factor of 4 over 3. So let's do it. The y value here is 0. Negative 3 quarters times 0 is 0. That's an invariant point. It did not move. 1, the y value here is 1. 1 times negative 3 quarters is negative 3 quarters. The y value here is 1, right? There's your y. 1 times negative 3 quarters is negative 3 quarters. The y value here is 4. 4 times negative 3 quarters is negative 3. 1, 2, 3. Sorry? Factoring out the k to get the correct transformation. If you do not see, looking at that, you're going to say that's 2 to the left. Yeah, of the x, okay? But with it, now that I've factored out the k, it's really 2 to the right. Okay. So this is 4. Negative 3 quarters times 4 is negative 3. This is 9. 9 times negative 3 quarters is negative 27 quarters, and that's equivalent to negative 6 and 3 quarters. Again, here the y value is 9. 9 times negative 3 quarters is negative 27 over 4, and that works out to negative 6 and 3 quarters. There's my number 2. See how I'm labeling? I have my legend over here. That's equation 1. That's equation 2. Bring colors on your test on April the 4th, okay? And it will help. Now we have a reflection in the y-axis. So this branch will go there, and this branch will go there. It's exactly the same thing, right? So I'm going to write 3 here. But this is actually equation 2 and 3, or transformation 2 and 3, and I'll put this is 3 and 2. So this graph is exactly the same thing, right? Because it's symmetrical about y, and when you reflect about y, you get the same thing. So let's now do the last graph. Okay, so now I'm going to go 2 right, down a half. Right 2, down a half. 1, 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 2. Okay. That's our equation number 4. Okay, there, we've graphed it using transformations. Yes. Okay, in step 3 what happened was, this is a reflection in the y-axis. Notice that this graph is symmetrical about y. So that point is reflected to there, that point goes there, that point goes there, right? And then this point goes there, this point goes there, and this point goes there. So graphs 2 and 3 are identical. They're exactly identical. Okay? From the negative. That's a reflection in the y-axis. Reflection in x-axis, reflection in y-axis. Okay, description. Okay, reflection over x-axis. Over x-axis, right? Now, I'm going to show you two ways to describe this. We can either call this a vertical compression by a factor of 4/3, right? By the reciprocal. Or if you feel more comfortable, why don't I write that over here? Because you're going to run. Or you could describe it as a vertical stretch by a factor of 3/4. Okay? Either one is correct. But if you call it a compression, don't use 3/4 because 3/4 is less than 1. It's almost like a double negative. You're compressing and you're compressing twice. That doesn't make sense. So you have to do it by the reciprocal, or if you find that easier, just call it a vertical stretch. Number 3 was reflection over y-axis. Number 4, notice before I go on, I'm doing it all in the correct order. Stretches, compressions, and reflections before the translations. So number 4 is horizontal translation right to. Number 5, vertical translation I'm sorry, it's getting squishy. Translation down 1/2. Can I read anything out here for you? I realize it's pretty tight. Okay. Yes. No, if you want to go down 1/2 and write 2, or if you want to go right 2 then down 1/2, it'll get you in the same spot. So this is okay, but you want to do these before you do your translations. Let's do domain and range. Well, domain is anything in the set of real numbers, and range is y such that maximum y value can be is -1/2. Okay, so y such that y is less than or equal to 1/2. Y is an element of real numbers. I'm going to do one more with you. Because it's different. I can post the answers to the ones I skip over. Okay. So again, always remember to factor out the k. Y equals 0.5 f of 0.5 x plus 2 minus 4. You realize that a equals 0.5, k equals 0.5, d equals negative 2, c equals negative 4. Because it's 2 to the left, 4 down. You have to be able to read both types of notation. Notations like this and notations like this, okay? Here they call the function f because they drew f for you, okay? So they drew the parent function for you. We're going to apply these transformations to the parent function that's given. I'm going to write the steps here. Number 1, my legend here. Y equals f at x. So this is a vertical compression by a factor of 2. Here the y value is 0. 0.5 times 0 is 0. That's an invariant point. Here the y value is 2. 0.5 times 2 is 1. Here the y value is 0. 0.5 times 0 is 0. Here the y value is negative 4. 0.5 times negative 4 is minus 2. Here the y value is 2. 0.5 times 2 is 1. So this is where bring rulers and colored pens to the next test. This will help. Okay, now now we're going to continue. This is a horizontal stretch by a factor of 2. So we're going to graph y equals 0.5 f of 0.5x. So we have to be careful to stretch horizontally the red graph, not the black graph, but the red one. So here we're stretching all the x values. X here is negative 3. 2 times negative 3 is negative 6. Here x is negative 1. 2 times negative 1 is negative 2. Here x is 0. 2 times 0 is 0. Here x is 2. 2 times 2 is 4. Here x is 3. 3 times 2 is 6. So now I can join my dots. Now I can go 2 left, 4 down. The pen's no good. Let's see. I guess I can do it in red. 1, 2, 3. Oh, sorry. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. This is graph number 3, which is y equals 0.5 f of getting a bit smudgy, but yes, Michael. How do you do 1? Step 1. Step 1 was a vertical compression by a factor of 2. So my original was here. Notice this applies to the y values. The x values don't change. So y here is 2. 0.5 times 2 is 1. Here the y value is 4. 0.5 times 4 is 2. So let's describe them. Again, notice I'm drawing using transformations in a very specific order, right? I'm doing the stretches, compressions, reflections before I do the left, rights, and up and downs, okay? So let's describe them. 1. Vertical compression by a factor of 2. Or, if you prefer using the word stretch, you could describe it like this. This is an or. Do one or the other. Don't do both. Vertical stretch by a factor of 0.5. Okay, number 2. Horizontal stretch by a factor of 2. And there's no or there because we're using the stretch word, right? Yep. Yeah, the K. Always think of whatever we apply to X, if it helps you remember, think of X as being disobedient. It's like you're telling it to compress, but really stretch. X is going, no, I'm not compressing, I'm stretching by a factor. If you think of it as X is disobedient and Y is obedient, it might help you remember. Right? And here you're thinking you're going 2 to the right, but no, you're going 2 to the left. All right. Number 3, horizontal translation left 2. 4, vertical translation down 4. All we have to do is state our domain and range, and that will be it. The smallest value x is 1, 2, 3, 4, 5, 6, 7, 8, negative 8. And this is, largest value x is 1, 2, 3, 4, right? It's right here, right? It starts here and ends there. So we can say our domain is x such that negative 8 is less than or equal to x is less than or equal to 4. X is an element of real numbers. Range y such that, okay, the smallest value y can be, it's there, 1, 2, 3, 4, 5, negative 6. And the largest value y is there, which is negative 3. So negative 6 is less than or equal to y is less than or equal to negative 3. Y is an element of real numbers. Michael and then Richard. Sorry? This one? Alright. So this affects your x values and it's a horizontal stretch by a factor of 2. So, because it's beside the x. Do you see here? This affects the y when it's outside the function. Like for example, if you have 0.05 root x, this is a vertical compression by a factor of 2. That's this 0.5. However, if it's like this within the square root sign, then that's a horizontal stretch by a factor of 2. So that's like that guy there. See how they're indicating it inside? Here it's inside the square root side. Here it's inside the function, which they drew down here for us. Richard, did you have a question? Oh, I thought you had your hand. Okay. Yep. Yeah. So here, let's see. I am changing the red one. So here the x was negative 3. Negative 3 times 2 is negative 6. Here the x was negative 1. Negative 1 times 2 is negative 2. Because it's a factor of 2. It's a horizontal stretch by a factor of 1 over k. Horizontal stretch by a factor of 1 over 0.5, which is 2. Think of x as disobedient. Okay. Okay? Yep. I wasn't going to. I can. Would you like me to? Okay, so let's do number 6. Sure, why not? Okay, so now this is a square root function. And the first thing we're going to do is rewrite the equation because notice k is negative 2. So y equals 1/2 square root of negative 2 times x minus 3 and minus 3 outside. No, this affects the y. When it's outside the square root, that this affects the y. Anything in here affects the x, or the horizontal, and these guys affect the vertical. Okay, so I'm going to write the equations here because I need a little bit more space here for other things. So don't forget to label your axes. So let's draw the parent function. Since you see a square root sign, the parent function is y equals root x. So again, by now the basic parent functions are, you should know by now. When x is 0, square root of 0 is 0. When x is 1, square root of 1 is 1. When x is 4, 1, 2, 3, 4, square root of 4 is 2. When x is 9, square root of 9 is 3. 1, 2, 3, 4, 5, 6, 7. That's our number 1. Now we're going to do our second transformation. I'm going to use black again. Now I'm going to do the vertical compression by a factor of 2. Okay, so just very carefully, here the y value is 0. 1/2 of 0 is 0. That's an invariant point under this transformation. But 1/2 of 1 is a half. 1/2 of 2 is 1. 1/2 of 3 is 1.5. There's number 2. Let's do number 3. Number 3, we're going to reflect and compress by a factor of 2. So, maybe I better do it in red. We are going to handle the x. There's 3. Y equals negative 1/2 square root of negative 2x. I'm going to handle the reflection over y together with the horizontal compression by a factor of 2. So I'm going to multiply all the x values by a negative half. Here the x value is 0. Negative 1/2 of 0 is 0. That is an invariant point under this transformation. Here the x value is 1. Negative 1/2 of 1 is negative a half. See how I'm going negative a half in the x direction? The y value in this transformation does not change. I'm only changing the x value. Here the x value is 4. Negative 1/2 of 4 is negative 2. So that's going here. Here the y value is 9. Negative 1/2 of 9 is negative 4.5. There. Let me just draw that in right now. Did I make a boo-boo? Okay, this is the effect on x is 1 over k, so 1 over 2 is a half. Okay, think of x as disobedient. You think you're stretching it, but in effect you're compressing it by a factor of 2. Y is obedient. You say a half, you stretch it by a half, or you compress it by 2. But x is, he's saying, I'm not listening to you, I'm doing the opposite. That might help you remember. Emma? Oh, this should be positive, right? Was that your concern? Oh, okay, I'm sorry. Oh, I'm so glad we straightened that out. Okay. Yes. 3 or 4. Do as many as will fit on the grid. My humblest apologies. Okay, guys, let's finish this off. We're almost done. Now we have to do is go 3 right and down 3. 3 right, down 3, and we'll be done. So number 4, maybe I should write it in red. Y equals 1/2 negative 2x minus 3 minus 3. Okay, 3 right, 1, 2, 3, down 3. 1, 2, 3. No, that's a positive half. That's a equal. Yeah, that's the equal sign. Yeah, I'm trying hard not to do that again. Okay. Okay, 3 right, down 3. 1, 2, 3. 1, 2, 3. This point, 1, 2, 3. 1, 2, 3. And the next one will go off the grid, so I'm not... Oh, did I do the wrong one? It is the wrong one. Okay. This one at least is easy to fix because when I draw it this way, I won't mess anything up. Okay. 1, 2, 3. Uh-oh. Yeah, that one's... This one's okay, right? 1, 2, 3, 1, 2, 3. Oh, yeah, here. 1, 2, 3, 1, 2, 3. All right. 1, 2, 3. What's the matter now? Okay. 1, 2, 3, 1, 2, 3. Okay, we're good now? Okay. 1, 2, 3. Good? Okay. So let's describe it now. I do apologize for that. Okay, description. 1. And for the sake of time, I need to rush this a bit, but I want to get in the... I'm going to finish at 5 to 3, okay? And then we have to call it. Vertical compression by a factor of 2. 2. Reflection over y-axis. 3. Horizontal compression by a factor of 2. Or, if you want it, but I don't think it makes it easier if you call it a stretch, horizontal stretch, by a factor of a half. 4. Horizontal translation right 3. 5. Vertical translation down 2. And just for the sake of time, because our time is almost done, here's the domain and range. Yes. Down 3. Thank you. X such that X is less than or equal to 3. Y such that Y is less than or equal to, no, greater than or equal to negative 3. Okay? I'm pooped. I don't know about you. Okay? Sign off.